All right, here we go. So we are on 4A. We're talking about polynomial and rates of change. Do you guys remember our polynomial functions? Polynomial functions are basically all majority of the functions. The smallest polynomial function is a constant function. It's a polynomial of degree 0. Ringing a bell? Then linear is a polynomial of degree 1. Then quadratic is a polynomial of degree 2. And then a cubic is a polynomial of degree. And it just keeps going, right? Those are our polynomials, okay? So we're going to identify some of the key characteristics of polynomial functions and how they relate to rates of change, okay? The main thing is that we're going to make sure we can identify our maximum, or not a maximum, what do they call it? Maxima and minima of our functions. So just remember, this is the general form of a polynomial. It's one term plus another term plus another term as your power of your variable is decreasing in size, right? Remember that? So for example, we could have a polynomial of the form you were just writing in my last period. So why would you stop writing in this period? It depends. There we go. So if we had P of X equals 4x to the 5th minus 2x to the 4th plus 6x to the 3rd minus 2x squared plus x minus 6, right? That's what it means that this is the standard form of a polynomial. There is the powers can't be negative. The powers can't be fractional. Yeah. And so from there, we should be comfortable with identifying the degree of this polynomial. So if I ask you for the degree of this polynomial, we all should say what? Say it again. 5. Why is it a degree 5? It's my largest power, right? Okay. Next, we should all be able to state the leading coefficient. What is my leading coefficient? 4. Why is 4 my leading coefficient? It is the number with the highest variable power. Yes? So that's my leading coefficient. Yeah? All right. Now, next points are turning points. When we talk about turning points, we're talking about when it goes from increasing to decreasing. We change in the directions. So we're going from whether it's a maximum to a minimum and minimum to maximum. The max number of turning points that you can have is n minus 1, n being your degree. So for this polynomial, it can have up to 4 turning points. Does that make sense? Yes. Okay, because it's a degree 5, right? And it's going to be whatever you're in, that's your degree. And your number of turning points is always 1 less than your degree. So our max for a 5th degree polynomial would be 4. Yes, thank you. I didn't mean to write that. 4 turning points. 4 TPs. Okay. Directions. So remember end behavior. Do you remember our stick man? Our dancing stick man? Our end behaviors? Anyone remembers him? Okay. Yeah. His little dances that he can do as his end behavior. All right. If I am a positive even, what are my arms doing? Oh. I'm waving them like I don't care, right? Remember this? So our positive evens, we're waving them like we don't care. What are our negative evens doing? They're going down, right? They're going down. If I am a positive odd, what am I doing? Up. Up, down on which side? Right, up. It should be my right goes up and my left goes down, right? Your positive negative determines what's happening on your right-hand side, right? So if I'm a positive odd, we were doing this. Doot, 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 stand a line. Okay? If I am a negative odd, it's the opposite way. I'm going to end negatively, but start positively. Yes? Okay? I know y'all make fun of my little figure that I drew, but hopefully y'all remember his dance moves. He only had 4. Huh? I didn't draw him. I made him using the tools on PowerPoint. But yes, you know what I meant. Okay? All right, but that's where we're at. So what we're going to practice is you're going to practice these skills, my friends. I'm going to do number 1. And then you're gonna do B and C at your table. And we're gonna do it fairly quickly. Cool? All right, so number one, I'm not graphing, I'm just looking and identifying. Okay. So number one, my leading coefficient is -5. Agree? My degree is my number of turning points. What is it? It's 3. It's going to be your degree minus 1. And so my max turning points, my max is 3. Yes? Are we cool? On B, you're going to do the same. On C, I need you to practice distributing and then doing the same. Got it? All right, go. I'll be walking around if you need me. On C, you're going to have to distribute. All right, so on B, what was my leading coefficient? 2. Don't let the order fool you. What was the degree? And therefore my max turning points was, or is. All right, on C, you either could distribute or you could have did FOIL first. Doesn't matter which one you did. No, I would probably just have distribute first, which would have led me with x to the third minus 4x times 10x plus 5. And then I would have FOIL. So I get 10x to the 4 plus 5x to the third minus 40x squared minus 20x. So my leading coefficient is 10. My degree is, and my max number of turning points is 3. No, I'm just doing it for our notes. Yeah. So that you understand that it's not guaranteed, but this is the most I can have. Yes, hold on. How is the, which one? Because it's x cubed times 5. I distribute my x first. I distribute my x, and it became x cubed, and then this became 4x. I'm putting max just to reiterate the fact that this is the max it can have. Okay, it's the max number of turning points. Okay. Yes. My handwriting. Sorry. If they look like K's to you, I'm sorry. He said my X's look like K's. I don't know what to tell you. All right, so we're going to talk about local extrema. So your local extrema is basically saying what is your highest point or your lowest point. Absolute, that's a local extrema. So where are you making those valleys and mountains at? Does that make sense? So we're looking for where are we creating those points at? So when F has a local maximum at B, that means it's called a relative or local. So you may see it as relative. And in some places, they may call it a local maximum. Okay. So looking at our chart, where do we have maximums at? Here, and it's not quite at -2 and it's not quite at 2. Do you see that? So these would be our local max. Yes? In this case, it's the same. Your local is just saying it's creating that mountain. Yeah. All right, our local minimum. So our local minimum, again, it can be called a relative or a local. So it can be called a relative or local. So key thing, how I remember, think mountains and think valleys, right? Where do I have a valley at? Here. So this would be a local or max, okay? This one, notice I specifically labeled as a local min, not my absolute. That's because the graph is going on what? Infinitely. It's still going down, okay? So this is a local min because there's things that happens past the valley. Make sense? These are absolute max because is there anything taking place past them? No, there isn't. Okay? How do we feel? Good? Keep them pushing. Okay, so on the graph over here, we're going to shape the intervals of increase in green and the intervals of decrease in red. If you don't have that, you can kind of just do like lines or just label I and D. Okay. However you want to do it, it's up to you. So we're going to go through and label our intervals of increase and our intervals of decrease. So we're going to start off with increase. So I'm going to label where I increase in green. So where do I start? That's an increase, right? And then this is also an increase. Agree? Now we're going to highlight our intervals of decrease in red. So we're going to do decrease in red. It's a little wavy. Pretend that it's straight. Or you could just write I, D, and I. and I. Okay, so now we've already done this, and we said when we're stating intervals of increase and decrease, what do we use? We use intervals, but what kind of, we use brackets. Okay, for numbers, we're going to use brackets. The only thing we can't use a bracket with is what? Infinity. Okay, so when we state our interval of increase, so I, where are we increasing from? Good job. Negative infinity to -1, and we're going to use a bracket. Where else do I? And what's with that too? Bracket. Yes. All right. Our interval of decrease. Interval of decrease. Bracket. There we go. Okay, so that's what we talked about before. Are we comfortable with B? Everyone's golden at B, right? Okay. On C, this is where our extrema. Anytime it asks for an extrema, that means you're asking for a maximum or a minimum. That's what extrema means. Okay. Think about extreme. What's your extreme high and extreme low? Okay. So we're talking about our extrema, and we're going to ask ourselves, where are they? So we're going to label them on the graph. Okay. Again, for maximums, we're looking for mountains, and for minimums, we're looking for valleys. So in this case, this is a local max. And why am I specifically saying local? Something goes past it. Make sense? Okay. And this is going to be a local min. And why?
Because the line goes down.
And the line goes down. Yes?
Yes.
Okay. When you're writing where your locals are at, you use the X value only, unless it says what is the value of you're going to identify where it's located. So we have a local max at X equal what? -1. And then we have a local min at 2. I was writing it, but then I made a mistake, so I had to stop. At x equals 2. Okay. Again, we're saying where they're at, not what's the value. Got it? I'm trying to save trees. I'm trying. Okay. But I don't want y'all to have to write so much completely in your notes. But at the same time, trying to save trees. Okay. Trees. All right. What is the connection between the relative extrema and the intervals of increase and decrease? What do you notice? Where do our max and mins take place? At the what? At the turning point. It takes place at the turning point. That's when we change directions, right? That's when our graph changes direction. Make sense? That's where my blue, my green and my red meet, right? That's where I'm creating the mountain or the valley. So because of that, how many turning points are there? There are 2 TPs because I have 2 turning points. What is the... Good job. You didn't let me finish. But yes, what's my least possible degree? So because there's 2, can I write TPs? Will that bother y'all? All right, TP. There are 2 turning points. So the smallest degree possible is 3.
I think I'm already said it like already said
Here is 3. Make sense? Because when we talked about degree of 3, what was the max number of turning points it could have? All right, so what you're about to do on example number 3, at your table, you're going to go through. Oh, that's not what I wanted to hide. You're going to go through and you're going to circle your local extrema. And you're going to identify each of your zeros, aka your x-intercepts. Quickly, very quickly. And then tell me, what do you notice about your zeros and your local extrema? Yeah. All right. So, when you went through and you circled all your, I'm gonna sort of circle. I'm gonna highlight just because me and circles aren't friends. Okay. So we have a max, a min, a max. Yeah. A min, a max. Yeah. A min, a max, a min, a max, and a min. How we do? Okay. Now we're going to identify our zeros. So here's a 0. Here's a 0. Here's a 0. 0. 0. 0. Here's a 0. Here's a 0. Here's a 0. 0. 0 and 0. So what are some things you noticed about this? They are, there we go. You're so smart. Our extremas, or our extremas are between the, I can't write, zeros, or what? Oh, there we go. Or are the zeros. Make sense? Okay, our extremas are between the zeros, or our extremas are the zeros. Got it? Yes? Makes sense? We see the connection? Okay, so we kind of briefly talked about absolute. Now we're going to specifically talk about it. What about an absolute or a global extrema? Again, it just depends on what textbook, what language you're using. But absolute and global extrema means that on the domain that you have, this is the absolute highest you can go, or the absolute lowest you can go. Is that okay? That means your range has some type of restriction, right? Your range can't be going from negative infinity to positive infinity. There is a restriction on your range. Make sense? All right. So if we look at the one that we have here, I don't know if y'all can see the points, but I'm going to label them to make sure that we're all on the same page. So this is at -3, -5. This one's at 1, 3. And this one's at 3, 1. Agree? All right. So if we're looking for our absolute, is there an absolute high construction? All day. Yeah. I know, all day, Hudson. It's even worse right here. Like, no, it's right here by the window. Absolute maximum. Where does the absolute highest y value exist? At 1, 3. So my maximum is f of 1 equals 3. Yes? Absolute minimum. What is the smallest y value I can get out of this? So at f equals -3, and that's going to produce -5. Doable? Did we survive? Any complaints? Maybe later, really? Oh my gosh. Moving on. What are we waiting for, Hudson?
Me too. I was sorry.
So you chose to relax in that moment? Oh. All right, here we go. So we're going to be defining our relative absolute maximum minimum. So here's your formal definition. It's already written out for you. Can someone please read the definition of a relative or local extrema for us? Oh, okay, I didn't know it was a speed read, but good job. Thank you. All right. Someone read our absolute or global extrema. Hit it, Max. Doable? Can we do those? All right, you're going to do them now. Okay, so you're going to do example number 4. You have A, B, C, and D. I want you to go through on A, B, C, and D and identify where's your relative max, relative min, and if there's an absolute max and an absolute min. Okay. Is there guaranteed to be one? No. Is that okay? Yes. Okay. So you're doing all 4 of them. Got it? If there isn't one, then you write none. All right. Okay. I'm going to put up 3 minutes. I think we can do it in 3 minutes. No. Just identify, where is it? No. Yes, there will be. All right, so here we go. On the first one, we're gonna go through and identify our maximums and minimums. So up first, is it okay if I just put R and A for relative and absolute? Is that gonna bother anyone? All right. So for an R max, does it exist? I do have a relative max. Right there. There is a relative max, okay? And my relative max is at f of 1 equals 5. I'm just going to write it all together. So at x equals 1, I have a relative max, correct? Do I have a relative min? Where's my relative min? You can write it out. I'm just being very general, broad, very specific. Complicated? Very general, broad, very specific. Yep, I said all the words. All of them. Take it however you want to take it. That's what that means. All right. Do I have any absolute? No abs.
There's no abs?
No abs. Why are there no abs?
There's no absolutes because one goes up.
Exactly. I'm forever going down and I'm forever going up. So I can't have an absolute on my range. Does that make sense? All right. Next, over here. R max. Do we have an R max?
Yes.
Where? We have an R max here, right?
You didn't count.
We have an R max here.
You have two R maxes?
Huh?
You have two R maxes?
Mhm.
Oh, okay.
Yeah, you get relative. So we have one at F -3. And I have, but what about this one? Is it really an R max? What is this one? That's gonna be an A max, an absolute max.
Oh.
Because is there anything that go past it? Anything goes past it? No. So at F of 2, it's my absolute max at 8. All right, what about my minimum? Where's my R min? At -1.
Oy.
And what's its value, just for making sure we're comfortable reading it? And do I have an absolute minimum? No. No minimum. Abs. Yes? Are we catching on? Do we get it? Anyone's like, no? Are we okay? Okay. All right, on this one. What about R max? Where is it at? Can't really. 3.5? Isn't that 3.5? At 3.5. Okay. What about our R min? 2, -2. Do I have any absolutes? Why do I not have any absolutes? Double infinity, right? Okay. Last one. What was your relative max? Any relative max? Where is it? At x equals what? -0.8. What about my relative min? X equal what? -2. And then I had a what? An absolute. I had an absolute minimum. And where is that at? At x equals 2. Yeah? All right. So we confident, comfortable? Any questions, comments? Okay. You should have already did it. I don't even. All right. So here we're just gonna reiterate how can we identify the key concept from polynomial functions of an even degree will have either global maximum or global minimum. Did anyone catch on to that? Yes. So if I am an even function positive, I'm partying everywhere. Woo! That means I have a low, right? Because both of my end behaviors are going up, right?
Yes.
If I'm an even function, I'm like, oh man, I'm tired of being at this party. I'm gonna have an absolute max. Make sense? So without graphing, without looking, we can easily or try to identify whether there's a global minimum or maximum taking place. Okay, before we graph. Does that make sense? So let's give it a shot. And then we'll verify with graphing. So looking at this, what am I? Even or odd? I'm an even. Why am I even? Okay, so we know we're even, correct? And we are positive or negative? Positive. So based on knowing that, I should have what? If this is going to lead to an absolute minimum, right? Positive. Okay, I'm at even positive. So that means I will have an absolute minimum. Yes? Make sense? Okay, so look at B. We're going to graph and verify in a second. Looking at B, I'm a what? What if I'm an odd? and I am positive. Because I'm on odd, will I have any absolutes? No, because what are we doing? Staying alive, going different directions, right? So therefore, there are no absolutes. Make sense? All right, so what we're going to be doing here is we're going to be practicing in the calculator and using the calculator to identify our maximums and our minimum values, okay? We're focusing on value. And when I say find the value, so when you hear the word value, that means I want to know what is your y. Where is your x? Value is your y. Make sense? All right. So I'm going to go to my handy dandy calculator, bringing out good old Sylvie, turning her on. And I'm going to put in the first equation. So we have x to the 4 minus 3x to the 3rd plus 4x. Ah, fudge. Thank you. I forgot to arrow over. All right, am I in? That's good. She's coming. Sylvie draws a little slow. We don't judge her. We let her be great. Okay. So we're good? Everyone's ready? Huh? A. So I have my graph in. If the view bothers me, could I zoom in? Yes, I can zoom in. Was it really bothering me? No, but I'll zoom in. Sylvie's just gonna take a minute. Look at her. I zoomed in too much. So I'm gonna go to second. I'm just gonna go to window settings. I need to go up a little bit. Okay. You guys have to learn how to be comfortable with manipulating your graphs on your own. It's for your comfort, your viewing. I will not come and alter your graph settings for you because you need to be comfortable and doing it yourself. All right, so I'm comfortable with what I see. I am not going to draw the exact graph. I'm going to just kind of do a little sketchy sketch of what I have. So I know I go like this, and I go like this, and I go like that. Perfect. And then I'm going to draw in my lines because if I, yep, it's exactly what's up there. Beautiful. Nope. I don't know why, but PowerPoint doesn't have one. They never put it back on here. My Mobi board, they never installed the software back. I know. So you guys get these beautiful curves and lines that you're going to cherish for the rest of your lives. All right, in the calculator, I need to be able to find those said values, right? In order to find the values, I'm going to find my min. I like to work the graph from left to right. So I'm going to press. Anyone remembers what do I press to find a min and max in the calculator? Second trace. So we're going to go second trace. And I'm going to look for my minimum because starting from the left, I have a minimum. I'm going to take my cursor, my little spider. He's going to crawl over here. It says go left bound. That means you have to be to the left of where your minimum is located. And you press enter. And then it's going to say go to the right of it. I'm going to listen. And my spider is going to crawl to the right. And I press, he's like, oh, you want me to guess? No, I did all this for nothing. And then you hit enter. And it's going to say your minimum is located here. We're looking for the minimum value. So what do I want you to tell me? The y. If I'm looking for the minimum value, so my first minimum is at y equals negative 1.623. The next thing that I want to find traveling along is going to be a what? A max. So when I hit second trace, this time I'm going to go to So second trace, and I have a maximum. So I'm going to go down to 4, and now I'm going to make my way towards where the maximum is. I need to be to the left of my max. I am. And then I need to go to the right of my max. As long as you're to the left and to the right of it. I can tell you how far to go. Yep. All right, so we have y equals, and that puts us at 2.08. And then the last one, do I really need to put it in? No, what is it? 0. Our minimum at 2 is going to be 0 because it's on the x-axis, right? So looking at what we have, what is our absolute? There we go. This is our absolute. That is the smallest. So that's our absolute. The others are just locals. Right, Anthony? So this is what you're going to be doing. So now you're going to go through, practice graphing, and then identifying where the max and the min are using the handheld device. If you don't practice a skill, then of course you're not going to be able to do it. All right, so I believe we're good. So I walked around, no one had, we answered all the questions. So we're going to move on from maximum and minimum and graphing and finding in the calculator. Cool? All right.